Welcome to my algebra class. We're on chapter 5, section 12. And we're finally going to take all of the material that we learned about how to factor a polynomial. And we're going to use that factoring now to solve equations that have a polynomial in them. And we're going to use what we call the zero product property. If I have x plus 3 times x minus 7 equals 0, then it's true that x plus 3 could equal 0, or x minus 7 could equal 0. So if I solve that, x could equal 3, negative 3, that would make a 0, and x could equal 7. So my solution would be negative 3 or 7 would work. In the second example, the 6x could equal 0, so x would equal 0. The x minus 2 could equal 0, so x could equal 2. And the x plus 6 could equal 0, so the x could equal negative 6. So my solution would be 0, 2, and negative 6. Those all work. In the third example, 3p could equal 0, and the 2p minus 5 could equal 0. So p could equal 0, and if I solve this, and divide by 2, I find out p equals 5/2. There's a quicker way to do this. If I have 2p minus 5 equals 0, I need a 5 here, so it'd be 5 minus 5 makes 0, but I have to get rid of the 2, so I just put 5/2. Example, if I had 3m plus 4 equals 0, I need a negative 4 here where the m is, but I got to get rid of the 3, so it'd be negative 4/3. If you learn that trick, you don't have to sit there and solve a two-step problem. One other thing, you have to make sure your equation is in standard form set equal to 0. So like this problem here, I couldn't work it out until I bring the 4k over. So it'd be minus 4k plus 4 equals 0. I'd have to subtract that and get it over there. Then it would be a perfect square trinomial. So my solution would just be 1, 2. This one would be bring the x, 0 equals x cubed minus 9x squared. And you want to keep the largest term positive, so that's why I moved the 9x squared over there. So I could pull out my x squared. I'd have x minus 9. So x squared could equal 0, and that would be a 0 for x. And x minus 9 could equal 0, so that means x could also be 9. So 0 and 9 would both work. So polynomial equations can be either cubic, where the largest term is to the third power, linear, where the exponent of the variable is 1, that's a straight line, and then quadratic, if it's a quadratic equation, the largest exponent is 2. So generally you'll see that if it is to the second degree, it has 2 answers. If it's linear, it has 1 answer, and third degree, it has 3 answers. And that'll show up later on. So we're ready to do the assignment. We're on page 232, and we're doing 1 to 36, the evens. So problem number 2. We have n plus 1 times the quantity n plus 9 equals 0. It's already factored for us. So n plus 1 could equal 0. And n plus 9 could equal 0. So our solutions are negative 1 and negative 9. Number 4, we have 2x times x minus 20 equals 0. So the 2x could equal 0, or the x minus 20 could equal 0. So in the first case, x would be 0. In the second case, 20. So either 0 or 20 would make this true. And you can plug them back in and see that. 2 times 0, that's 0 times anything is 0. 2 times 20 is 40, but 20 minus 20 is 0. So they work. Number 6, I have 2u plus 7 times 3u minus 1 equals 0. So the 2u plus 7 could equal 0, or the 3u minus 1 could equal 0. Now here's that trick again. Remember, I need a negative 7 here, but I got to get rid of the 2, so negative 7 halves would be the solution for that one. I need a positive 1 here, but I got to get rid of the 3, so 1/3 would work for that. So 7 halves and 1/3. Negative 7 halves and 1/3. Problem number 8, I have n times 5n minus 2 times 2n plus 5 equals 0. So the n could equal 0. I need a positive 2 here, so 2/5 to get rid of the 5. And here I need a negative 5 plus 5 would make 0, but I got to get rid of the 2. So those are my 3 solutions. Use that trick so you don't have to sit there and solve each one of them. Number 10, p squared minus p minus 6 equals 0. All right, these are not factored, so I begin my factoring process here. Nothing to pull out. It's a trinomial. It's not a perfect square, and product is -6, sum is -1. The two numbers that work would be 3 and 2. And the 3 would have to be negative. So it's p, take the square root of p squared, minus 3 and p plus 2 equals 0. And it's in standard form, so I can work it out from there. So the first one could be a 0. 3 would make that one a 0, the first factor. And the second factor, the -2, would work. So 3 and -2. Number 12, we have 0 equals k squared minus 12k plus 35. It is set in standard form. It's set equal to 0. Product, it's not a perfect square trinomial, and I don't have to split the middle because I don't have a number other than 1 in front. So product is 35, sum is -12. And the two numbers that work are 5 and 7, and they are both negative. So 0 equals, take the square root of k squared k. One of them is -5 and one of them is -7. So if the first factor was set equal to 0, then I would get a 5 to make that 0. And the second one, to make that 0, I need a 7. So 5 and 7 is my solution. 14, I have r squared plus 9 equals 10r. This is not in standard form. So I'm going to bring the 10 over by subtracting it and put it in decreasing order. So it's going to be r squared minus 10r plus 9 equals 0. Product is 9. Sum is -10. The factors that would work would be 1 and 9, and they'd both have to be negative. So go ahead and factor and set it equal to 0. Square root of r squared is r. One of them has to be -1 and one -9. So the numbers that would solve this equation would be, to make this 0, I need a 1. To make this 0, I need a 9. So my solutions are 1 and 9. And if you plug those in, they work. 1 plus 9 equals 10 times 1. And 9 squared, which is 81, plus 9, which is 90, equals 10 times 9, which is 90. Just realize you're finding the numbers that actually solve the equation by factoring. 16, you have x squared equals 20x minus 100. This is not in standard form. I'm going to bring these two to this side since the x squared is positive, and I want to keep it positive. So x squared minus 20x plus 100. When you move them to the other sides, they change their signs because you're doing the opposite. And the ends are perfect squares, so we'll see if it's a perfect square trinomial. Square root of x squared is x. The square root of 100 is 10. In the middle is twice the product, so they're both negative 10s. So we have what we call a double root. 10 works here and 10 works here, but we only write it once. So our solution is 10. Problem number 18, we have 9k squared equals 4k. It's not set in standard form, so we keep the 9k squared positive, and bring over the 4k and set it equal to 0. Factor, take out your k, and we have 9k minus 4 equals 0. So the k could be 0, and to make this 0 here, I need a positive 4, but I have to divide by 9 to get rid of the 9. So 0 and 4/9 would work. Number 20, I have 25m squared minus 16 equals 0. This is a binomial, can't pull anything out, and they're perfect squares, so I can factor it to 5m for the first term and 4 for the second. And one of them is positive and one is negative. For the first factor to become a 0, you need a negative 4, but we got to cancel out the 5. For the second one to become 0, we need a positive 4 there for m, but we got to cancel out the 5. So negative 4/5 and 4/5 would work. 22, we have 3x squared plus x equals 2. Get it in standard form, so it'd be 3x squared plus x minus 2 equals 0. It's not a perfect square trinomial, nothing to pull out. We have a 3 in front of the quadratic term, so we have to use product, sum, and split the middle. Product is negative 6, sum is 1. Two numbers that work would be 3 and 2. Since the sum is positive, the 3 has to be positive and the negative 2. So we can split the x into 3x plus 3x minus 2x minus 2 equals 0. Group, take out a 3x from the first two, that leaves us x plus 1. Checking the signs, positive, positive, negative, negative, take out a negative 2, and that leaves us x plus 1 equals 0. So our factors are x plus 1 and 3x minus 2. So for the first factor to make a 0, we need x to be negative 1. For the second one to make 0, this has to come out 2. But we have to get rid of the 3, so that's 2/3. So negative 1 and 2/3. 24. We have r minus 6r squared equals negative 1. We want to keep the quadratic term positive, so we're going to move these two to this side. So 0 and keep them in decreasing order. 6r squared minus r, because I moved it over, minus 1. I didn't move the minus 1. It's a trinomial. It's not a perfect square trinomial. I'm going to have to split the middle, though. The 6 in front of r squared forces us to do that. So our product is negative 6. Our sum is negative 1. The two numbers that work are 3 and 2. This time the sum is negative, so the 3 is negative. So 0 equals 6r squared, split the middle to negative 3r plus 2r minus 1. Group, you can pull out a 3r, and that leaves us 2r minus 1. From here, take out a positive 1, the signs are the same, and you have 2r minus 1. So our factors are 2r minus 1 and 3r plus 1. For the first factor to become a 0, you need this section here to be a 1, but we got to get rid of the 2, so that's 1/2. To make this a 1, you need a negative 1. Excuse me, to make this 0, you need negative 1 to get rid of the 3. So it's 1/2 and negative 1/3. 26, we have 2y squared equals 25y plus 13. Set it equal to 0, 2y squared minus 25y minus 13, keeping the quadratic term positive. Can't pull anything out, it's not a trinomial square. Product is negative 26. Sum is negative 25. Two numbers at work are 26 and 1, and the sum has to be negative 25, so it's negative 26. So we split the middle into negative 26y plus 1y minus 13 equals 0. From the first pair, take out a 2y. That leaves you y minus 13. From the second pair, the signs are the same, positive, negative, positive, negative. Take out a positive 1, and that leaves you y minus 13 equals 0. So our factors are y minus 13 and 2y plus 1. For the first factor to become a 0, you need y to be 13. For the second factor to become a 0, you need 2y to come out a negative 1, so we need negative 1/2. Get rid of the 2. Problem 28. We have 10u cubed minus 5u squared equals 0. It's in standard form. Factor out the greatest common factor, which would be 5u squared. That would leave us 2u minus 1 equals 0. For the u squared to be 0, you just need u to be 0. And the 2u minus 1, for that to become 0, we need this to be 1. So we need to divide by 2. So that's 1/2. Problem 30, we have 0 equals 10x cubed minus 15x squared. Take out your greatest common factor, which is 5x squared, and that leaves 2x minus 3. For 5x squared to be 0, you just need x to be 0. For 2x minus 3 to be 0, it's got to come out of 3, so we need 3 over 2 to eliminate the 2. (32), we have 6h squared plus 17h plus 12 equals 0. Nothing to pull out. It's not a perfect square trinomial. Product equals 72. Sum equals 17. So the factors that work that make 17, 1 and 72, nope. 2 and 36, no. 3 and 24, no. 4 and 4 goes in there 13 times. Excuse me, 18 times. That isn't going to work. 6 and 12 work. Nope. 8 and 9. So we need to split the middle and use 8 and 9. So we get 6h squared plus 8h plus 9h plus 12 equals 0. From the first pair, you can take out a 2h, and that leaves you 3h plus 4. From the second pair, you can take out a 3, and that leaves you 3h plus 4. So our factors are 3h plus 4 and 2h plus 3 equals 0. For the first factor to become a 0, we need it to be -4, so -4/3. And the second one, we need this to be -3, and use the 2 to get rid of the 2 there. (34). We have 25x squared minus 90x equals -81. I'm going to set it equal to 0, so 25x squared minus 90x plus 81 equals 0. Well, the ends are perfect squares, so we'll go ahead and try it. See if it's a perfect square trinomial. The square root of 25x squared is 5x. The square root of positive 81 is 9. 5 times 9 is 45x. The middle is twice that, so they're both negative. And that's a double root, so to make this 0, we need a 9/5. And that's your solution. And the last problem, 36. We have 6c squared minus 72 equals 11c. Keeping the quadratic term positive, we're going to pull over the negative 11c and make it negative and get it in decreasing order. Minus 72 equals 0. Okay, our product, we can't pull anything out, so our product is $432. And our sum is -11. Make sure I got that right. 12, 432. Okay, 1 and 432 don't work. They're going to be close. 2, 3, 4. See, 9 goes in there. Nine and 36, 40. 9 goes in there. 4 times 36, 72, 48. That's not going to work. 11 doesn't go in there. 12. See, 12 goes in there. 36. 36 from 43 is 72. 12 is, that doesn't make sense. All right, 12 goes in there. 432. It goes in there. 3. 36. 72, which is 36. 12 and 36. They're not 11 apart. 13, 14. Okay, 432 divided by 16. Okay, we got 16 and 27. And they differ by 11. So it's going to be 16 and 27. The sum is negative, so this 20. That's not going to work. That's going to be negative 432. All right, so we got 6c squared plus 16c minus 27c minus 72 equals 0. From the first pair, we can take out a 2, and it leaves us 3c plus 8. From the second pair, the signs are opposite. We can take out a negative 9, and that leaves us 3c plus 8. So our factors are, we should take out 2c, are 3c plus 8 and 2c minus 9. So the first one, we need a negative 8/3, and we need a positive 9/2. And that concludes the evens. And be sure and check the odds as you do the problems.